Hello, this is question 9 on your June 2018 paper 1 from Edexcel. It's a differentiation question. You have a sketch of this curve, this is the equation, and we have to find the derivative, or show that this expression here is question where I have x and y quite mixed together, which means the best way of differentiating this is just using implicit differentiation instead of just trying to make any of them the subject. So I'm going to use implicit differentiation. It's quite simple. What you are going to do is you are going to just differentiate in order what you have. So derivative of x squared is 2x. Derivative of 2xy is a product, so I'm going to use the product rule. I'm going to differentiate the first one. So derivative of x is 1 times y, so 2y. And then derivative of the second one, when I differentiate the y in implicit differentiation, I'm going to differentiate like if it was x, so derivative of y is x, is 1, but then I'm going to multiply by dy by dx, but that's what I have to do, so I'm going to leave this one as it is, 2x, and I'm going to differentiate y, which is 1, dy by dx. And then I have 3y squared is going to be 3 times 2, 6, y to the power of 1, dy by dx. So plus 6, y, and I need to add the dy by dx. And derivative of 50 is 0. And now I just make dy by dx the subject. So I have, I can factorize. So dy by dx in this side is going to be, well, I can divide everything by 2. Because I have 2, 2, 2, and 6. So dividing everything by 2 and factorizing dy, I have 3y minus x, multiplying dy by dx, and in the other side I'm going to have y, positive y minus x, which means that dy by dx is y minus x divided by this one. Let's check the signs because maybe the same. Sometimes you write the other way around, and that's fine. You just multiply everything by minus 1 and divide by minus 1, 3y minus x, and that's the expression that we needed to find. What I mean is, if you wrote this in the other way around and this the other way around, you just multiply by minus 1 and divide by minus 1, and you can change the signs of everything, to have the expression with the letters in the order that they have them. The curve is used to model the shape of a cycle track with both x and y measured in kilometers. The points P and Q represent the points that are farther west and farthest east of the origin. So P and Q are the more to the left and the more to the right, so farther north, east and farther west. Used in part A, so using the expression for the derivative, find the exact coordinates of the point P. So P is the one more to the left, or the one most west. What we know here is the tangent to the line, and I think that's why they represent these lines here. That's to give you the clue. The tangent to the line has vertical gradient. It's a vertical line, which means my derivative, which is giving me the gradient, is going to have denominator 0. When the denominator 0, I have a vertical line. So I'm just going to make 3y minus x equals 0. So for P, I'm going to make the denominator 0, so 3y minus x equals 0, which means I have 3y equals x, and I'm going to find the intersection between that line, which is the vertical, is the one giving me the vertical gradient, and the equation of this curve. I'm going to find 2 points of intersection. The one with negative x is going to be P. So I'm just going to do the intersection between that line, 3y equals x, and my function xy, plus 3y squared equal 50. I can substitute x here by 3y. So I'm going to have 3y squared minus 2 times 3y and so on. So I have 3y squared, 3y squared, minus 2xy, so minus 2xy, plus 3y squared is 50, plus 3y squared is 50, which is a quadratic in y. I'm going to find the two values of y, and I can find the two values of x, or just one, because I really just need one. So I have 9y squared minus 6y squared is 3y squared, plus 3y squared is 6y squared equals 50, which means y is going to be plus and minus root 50 divided by 6. If you simplify, is plus minus root 25 divided by 3, plus minus 5 divided by root 3, or 5 root 3 divided by 3. It doesn't matter at this stage. We need point P. We need point P. Point P has y negative, so I'm going to get the y negative and substitute to find the x. Yeah, I'm going to go back to the equation again. Oh, I don't need to do that. I know that x is 3y. So if y is the negative one, we say, because it's p, x is going to be 3 times that, 3 times y, which means is minus 5 root 3. So my point P is minus 5 root 3 minus 5 root 3 divided by 3. Yeah, and that's what we need to find, the coordinates of P. We just made the gradient infinite, or if you or just making this equal to 0, we have the gradient of the vertical line, and we substitute in our equation to find this point and this point. And that because are the points with tangent vertical, the only 2 points with vertical tangent. Yeah? Then they say C, explain briefly how to find the coordinates of the point that are farthest north of the origin. You don't need to carry this calculation, and it's just 1 mark. So the point farthest north, it will be the one with horizontal tangent, yeah, and that point is when y is equal x. If I do the intersection between y equals x and this line, I'm going to get the two points here that are the maximum and the minimum. Yeah, the maximum, it will be the one with positive x and positive y. So it's just explaining that with your own words. So for C, I'm going to make dy by dx equals 0, and to find maximum, then you will do the intersection. I don't know how much you want to explain, but it's just making the intersection of y equals x with your curve and choose the point that has positive x and positive y. Yeah, and that's all with this question.